In this video, the topic will explain is find the Fourier series expansion of the Fourier series expansion of the half wave rectified sine wave shown in figure below. This is the figure of t. Zero t by 2. This one is a t. Like that. X of t is like that here. A amplitude of the sine wave is A. Original sine wave is of t. Like that. 0 t by 2. This one is t. Minus t by 2. This one is minus t by 2. This one is here. This is the sine waveform. Expression of that sine waveform is x of t is equal to here. Some amplitude of the waveform is A. This one is minus A. A sine. We know that expression A sine omega t. That is equal to A sine omega is equal to 2 pi by time period of that waveform is this is the Tp. Let it be Tp. Time period of that periodic signal is Tp into T. Here Tp is equal to time period of that periodic signal is T. That is T. On complete full cycle. A sine 2 pi by T capital T into small. This is the example. Coming to this waveform, original waveform, this time period is represented by T naught is equal to small t naught plus capital T naught is T. Small t naught plus capital T naught is T. Small t naught is because the waveform is starting at this point and again the waveform is start at t is equal to capital small t is equal to capital. Initially the waveform is start at t is equal to small t is equal to 0 and coming to this point again that same waveform is repeated at small t is equal to capital. Therefore time period of the waveform is 0 plus t naught equal to capital T. Therefore t naught is equal to small t naught is capital T naught is equal to T. This is the time period of the half wave rectified sine wave. Half wave rectified sine wave. Now calculate quotients. Fourier series expansion quotients 1 by A naught. Not 1 by A naught is equal to 1 by T naught. T naught plus capital T naught x of t dt. X of t dt. Here we know that T naught is equal to T. This is the time period of the waveform. 0 T again. This is the T. T naught is equal to T. Substitute T naught value. T naught is equal to T. Small t naught is 0. 0 plus t naught value is capital T, x of t, dt. Here x of t is equal to a sine 2 pi by t. That is 1 by t integral 0 to t. X of t is a sine 2 pi by capital T into t dt. This is the x of t. This one is x of t, a sine 2 pi by capital T into small t. That is equal to a by t. Here the waveform is 0 to t by 2 has some value, t by 2 to t, that value is 0. Again split into a by, not a by, 0 to t by 2, a sine 2 pi by capital T into small t dt, plus t by 2 t, the value of x of t is 0. The value of x of t is 0. In 0 to t by 2, the value is a into sine 2 pi by capital T into t. In t by 2 t, the value is 0. Substitute 0 in that expression. That is equal to a by t. Integral of sine 2 pi by t is minus cos 2 pi by t by 2 pi by t. It was 0 to t by 2. Here the small t is there. Substitute limits in that expression. That is equal to a by t. Upper limit is minus cos 2 pi by t. Here t is t by 2. T is t by 2. T cancel. 2 cancel by 2 pi by t. 2 pi by t. Here minus into minus plus 0. Cos 0 is 1. 1 by 2 pi by 2. Here a by t. This one is t by 2 pi. Bring out t by 2 pi minus cos pi. This is the minus cos pi plus 1. Cos minus cos pi is minus cos. Here since cos pi is equal to cos 90 plus 90, that is minus sin 90. Minus sin 90 is minus 1. Therefore, cos pi is equal to minus 1. Substitute minus 1 in that expression. A by 2 pi minus into minus plus. A by 2 pi into 2. 2 to cancel. Therefore, finally, the a naught value is a by pi. A naught value is a by pi. Next step is find out a naught, an. An expression is 1 by t naught plus capital T naught x of t cos n omega naught t dt. Here t naught is equal to capital T. 1 by here 2 by t naught. 2 by t. Small t naught is 0. Small t naught is 0. 0 plus capital T naught is t. Capital T. X of t cos n 2 pi by t naught to t dt. That is equal to 2 pi t integral 0 to t x of t cos 2n pi t naught is t naught is t into t Again, in that interval 0 to t interval 0 to t by 2, that x of t is some value 2 by t. T by 2 t, that value is 0. There is no waveform is not maintained here. 0 to t by 2 x of t cos 2n pi by t into t dt. The remaining interval t by 2 t x of t value is 0. Substitute 0 into dt. That is equal to 2 by t integral 0 to t by 2. The x of t value here is x of t is equal to, we going to x of t is equal to a sine 2 pi by t into t. A sine 2 pi into t by capital T cos 2n pi by capital T into t. Here a values bring out a by capital T integral 0 to t by 2 2 sine 2 pi small t by capital T cos 2n pi by capital T small t into 2 sin A cos B. That is sin A plus B plus sin A. Sin A plus B plus sin A minus B. That is equal to A by 2 sin A. That is sin A is 2 pi t by capital T. B is 2n pi by t. This one is integral 0 to t pi plus sin A minus B. Sin A minus B means sin 2 pi small t by capital T minus 2n pi t by 2. That is equal to a by 2 integral 0 to t by 2. 2 pi by t is the common term in that one. Sin here tt is also common. 1 plus n 2 pi by capital T into small t dt plus split into two integrals 0 to 2 t by 2 sin 1 minus n 2 pi t by t. 2 pi t by t is the common term. 1 minus n 2 pi by t capital T small t into dt. That is equal to a by 2. Integral of sine is minus cos 1 plus n 2 pi by capital T into small t by 1 plus n 2 pi by capital T. The limits are 0 to t by 2. In the similar fashion, this one is minus cos 1 minus n 2 pi by t into t. One minus n 2 pi by t. The limits are 0 to. This is the entire substitute small t is equal to t by 2. Here a by 2 minus cos 1 plus n 2 pi by t. Substitute t value is t by 2 by 1 plus n 2 pi by t. Here substitute 0 here, lower limit minus into minus plus by 1 plus n 2 pi by t. T cancel. This one is a 2 cancel. Here this one is here minus cos 1 minus n 2 pi by here capital T. This one is capital T. Small t is t by 2 1 minus n 2 pi by t minus into minus plus 1 by 1 minus n 2 pi by here t cancel 2 cancel. Therefore here pi is bring out cos pi plus n pi. Cos pi plus n pi is cos 180 plus theta is minus cos theta, that is cos n pi minus into minus plus. Therefore a by 2 is equal to a by 2. Here pi is there minus cos pi plus n pi by 1 plus n 2 pi by t plus 1 by 1 plus n 2 pi by t. This one is 1 plus minus cos pi minus n pi by 1 minus n 2 pi by t plus 1 by 1 minus n that is equal to a by 2 cos pi plus n pi is cos 180 plus theta is minus cos theta minus cos n pi minus into minus plus. Therefore cos n pi by 1 plus n into 2 pi by t plus 1 by here also cos n pi by 1 minus n 2 pi by t 1 minus n 2 pi cos n pi is 1 a by 2 cos n pi is 1 by 1 plus n 2 pi by t 1 by 1 plus n 2 pi by t. This one is cos n pi is cos n pi value is minus 1 whole power n. Here cos n pi is minus 1 whole power n 1 minus n 2 pi by t is the minus 1 whole power n is a by 2 2 into minus 1 whole power n by this one is added 1 plus n 1 plus n 2 pi by t by 1 plus n 2 pi by t plus 1 by 1 minus n one more term is also there. It is plus minus 1 whole power n 1 minus n by two pi by t and 2 pi by t. Here in all the cases 2 pi by t is common term 2 pi by t, that is t pi 2 pi is the common term minus 1 whole power n by 1 plus n. Here minus 1 whole power n by 1 minus n. 2 pi by t is the common term, that is 1 by 1 plus n plus 1 by that is equal to a t by a t by this one is a by 2, this one is a by 2 here 2 sin a cos b. Sin a plus b plus sin a minus b. Here 2 is not required here. Here A by T. Here A by T. 2 is bring inside, this one is A by T. A by T. A by T. Is A by T. A by T here, A by T. One is A by T. This one is A by T. T by 2 by T by 2 by T is cancelled. That is A by 2 by. Simplification, this one is -1 whole power n is common term. 1 minus n plus 1 plus n by 1 minus n square. Here also 1 minus n plus 1 plus n 1 minus n square. Here the n cancel, 2 is there. Therefore, A by 2 pi minus 1 whole power n this one is -1 whole power n 2 pi 1 minus n square 2 pi 1 minus n square. That is A by 2 pi 1 minus n square minus 1 whole power n plus 1. 2 to cancel. This one is 2 to cancel. A by pi into 1 minus n square minus 1 whole power n plus 1. This one is A. This one is an. This one is an. Check the even for even values of n. For even values of n, that means n is equal to 2, 4, 6 and so on. Therefore, an is equal to A by pi 1 minus n square minus 1 whole power n minus, suppose n is equal to 2 minus 1 whole square, that is 1 plus 1, that is equal to 2a by pi into 1 minus n square. For odd values of n, for odd values of n, that is n is equal to 1 comma n value starting from n is equal to 1 to infinity. Split into 2 values, even values and odd values. N is equal to 1, 3, 5 and so on. For n is equal to 1, minus 1 whole power 1, that is minus 1 plus 1 is 0. Therefore, an is equal to a by pi into 1 minus n square minus 1 plus 1, that is 0. Therefore, an is equal to 0 for odd values of n. This is for even values of n. Now find out Bn. We know that Bn is equal to 2 by t, 2 by t naught plus capital T naught, x of t sine n omega naught t naught t. We know that here waveform is like that 0 to t, t by 2, 0 to t value x of t is there. This one is t by 2. This one is t. Therefore, t naught is equal to t. Small t naught is equal to 0. Small t naught plus capital T naught is equal to t. Put small t naught is 0. 0 plus t naught is equal to t. Therefore, t naught is equal to t. 2 by t. 0 to 0 plus t naught is 0 to t. X of t sine n omega naught is 2 pi by t naught into t. That is equal to 2 by t. Integral 0 to t, t by 2, x of t sine n 2 pi by t naught is the time period of the waveform is t naught is capital T into t d t. That is equal to 2 by t. One more integral is also there, t by 2 to t, the value is 0. Waveform does not maintain any waveform in that interval, t by 2 to t. Therefore, integral 0 to t by 2 x of t is a sine 2 pi by t into t sine n 2 pi by t. We know that x of t is a sine 2 pi by t into t. This is the waveform 2 sine a sine b. Any over integral, the sine term is 0. Therefore, that is bn is 0. Bn is 0, or else a by t 0 to t by 2, 2 bring inside 2 sine 2 pi by t small t sine 2n pi by 2 sine a sine. 2 sine a sine b means cos a minus b. That is equal to a by t integral 0 to t by 2 cos 2 pi by t minus 2 pi n by t cos a minus b minus cos a plus b. 2 pi t by t plus 2 pi n t. 2 sine a sine b is 2 sine a sine b is cos a minus b minus cos a plus b. Cos a minus b, cos a cos b plus sine a sine b minus cos a cos b. That is plus here is plus cos a cos b minus sine a sine b. Minus plus that is cancelled. That is finally 2 sine a sine. Here a by t integral 0 to t by 2. Here cos 1 minus n 2 pi t by t dt minus integral 0 to t by 2 cos 1 plus n 2 pi t by capital T Integral of cos is sine 1 minus n 2 pi t by t 1 minus n 2 pi by t over integral 0 to t by 2 minus sine 1 plus n 2 pi by t small t by 1 plus n 2 pi by t 0 to substitute small values t equal to t by 2, that is equal to a by t sine 1 minus n 2 pi by t value is t by 2, t cancel, 2 to cancel by 1 minus n 2 pi by t. This is the upper limit, the lower limit sine 0 is 0 minus sine 1 plus n 2 pi by t, small t is t pi by 2, substitute upper limit. Substitute 0 in the lower limit, sine 0 is 0. Here sine pi a by t sine pi minus n pi by 1 minus n 2 pi by t minus sine pi, here 2 to cancel, t cancel, 1 plus n 2 pi by sine 180 minus theta minus sine plus sine n pi. Sine n pi is 0. Sine n pi is 0. That is a by t sine n pi by 1 minus n 2 pi by t minus, here also minus into minus plus. Sine 180 plus theta is minus sine theta. Here minus into minus plus sine n pi by 1 plus n 2 pi by. This value is equal to 0. This sine n pi value is equal to 0. Therefore, finally, Bn value is 0. Bn value is equal to 0. But check n is equal to 1 for Bn. We know that Bn is equal to 2 pi by t naught 0 t naught plus t naught x of t sin n omega naught t. Here substitute n is equal to 1. Here t naught is, we know that t naught is t 2 by t 0 to t x of t. This is b1. N is equal to 1 sin omega naught t dt. That is equal to 2 by t 0 to t by 2 x of t sin omega naught is 2 pi by t naught plus t by 2 to t split into two intervals 0 to dt. This value is that is equal to 2 by t. In the interval 0 to t by 2, x of t is a sine 2 pi by t into t. This is sine 2 pi by t naught is t into t. That is equal to 2a by t, 2a by t integral 0 to t by 2 sine square 2 pi by t into t is the 1 minus cos 2 theta by 2. Cos 2 theta by 2. That is 1 minus cos 2 pi by t by 2 into dt. Here 2 to cancel. A by t integral 0 to t by 2 1 dt minus integral 0 to t by 2 cos 2 into 2 pi by t this value is 0. A by t integral of 1 dt is t 0 to t by 2. Therefore, a by t by 2 minus 0. Dt cancel. Therefore, a by 2. Therefore, b1 value is a by 2. We know that a naught value is already derived. A naught value is a by pi. An for even values 2, 4, 6 up to infinity. The an value is 2a by pi into 1 minus m square. For even values 3, 1, 3, 5, 7, a and so on infinity. An value is 0. Bn value is 0, but b1 is equal to a by 2. These are the Fourier series quotient. Substitute these quotients in that expression. X of t is equal to a naught plus sigma n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught. A naught sigma n is equal to 1 to infinity an cos n omega naught t is 2 pi by t naught into t plus sigma n is equal to 1 to infinity bn sin n 2 pi by bn is equal to 0 n not equal to 1. The remaining values 2, 3, 4, 5 and so on. The bn is 0, n not equal to 1. The n not equal to not equal to n is equal to 1, bn not equal to 2. The remaining values, this one is a naught, n is equal to 1 to infinity an cos 2n pi by t naught is t into t. For n is equal to 1, bn value is not 0. The remaining values b1 plus n is equal to 2 to infinity bn sin 2n pi by t naught into t. The remaining values n is equal to infinity bn is 0. Substitute values here. A naught is equal to a naught value is a by pi. A naught value is a by pi. For n is equal to even values, n is equal to 2, 4, 6 and so on so forth. A infinity. An value is 2a by pi by 1 minus m square. 2a by pi into 1 minus m square plus b1 value, b1 is equal to a by 2, b1 is equal to here b1 sin n value is 1, sine 2 pi by t. N value is 1. V1 value is here. V1 value is a by 2. V1 value is a by 2. Sine 2 pi by t naught is t. See the here cos 2n pi by that is equal to a by pi 2a by pi sigma n is equal to 4, 6 and so on infinity cos 2n pi by t into t by minus n square plus a by 2 sine 2 pi by capital T into small. For n is 2n, here n is replaced with 2n. Therefore, n value is from 1 to infinity. A by pi, 2a by pi. If n is equal to 1 to infinity, the n value is replaced with 2n. This is 1 by n is 2n whole square. Therefore, finally, a by pi plus 2a by pi sigma n is equal to 1 to infinity cos 4n pi by t into t 1 minus 4n square plus a by 2 sine 2 pi by t into this is the actual Fourier series expansion of the half wave rectified cycle. With this, the derivation is completed.